Coanda effect is a physical phenomenon that describes the tendency of a fluid, a gas or a liquid to stick to a curved surface as it flows. To understand Coanda effect, we need to understand Bernoulli's theorem and Newton's third law. The Coanda effect itself is explained in this slide, but then how does Coanda effect generate lift is what we are going to explain in this particular video, and we are going to see this because that is how our experiment is able to generate effect using the Coanda effect. So let's start by understanding what Bernoulli's theorem is. Bernoulli's theorem or principle states that as the speed of a fluid increases, the pressure it exerts decreases. In other words, the velocity of a fluid is inversely proportional to the pressure it exerts. If the velocity is high, the pressure is going to be low, and if the velocity is low, the pressure is going to be high. So let's understand the relationship between pressure and velocity. Let's consider a surface. This could be a table, or it could be your hand, or anything in this earth, and it's always surrounded by the atmosphere. The white dots are the uh, air molecules that surround the object. Now, let's look at one of these air molecules. This air molecule is always in random motion. It could be moving up, down, left, right, into or outwards. It's in very 3D. It's in a random motion. And sometimes what happens is that this air molecule might bombard or hit the surface. And as it hits the surface, it exerts a pressure on it. Just like if you were to touch your hand with your finger, you're in turn exerting pressure on it. Similarly, many molecules, as and when they move around, they occasionally hit the surface, and as they hit or touch the surface, they exert pressure on it. Now, here if you notice that the air molecules are in very slow motion, there is not much velocity. They are almost static, but then they tend to hit the surface, and then they exert pressure. Now, compare it to a situation where the air molecules are in motion. They are moving from left to right, and as the air molecules move or as they are in motion, they tend to interact less and less with the surface because they are more focused into the motion that they don't get enough time to interact with the surface. So in the previous image we had seen that around 5 or 6 air molecules had hit the surface, and they had more opportunity to touch the surface, so that the pressure is high there. Now if we see here, very less has the opportunity to touch the surface. Now comparing this with the previous image, since the air molecules are static or low velocity, the pressure was high since they were able to interact with the surface more. But here, since they were in high velocity or moving much, they were more focused on the motion that they were not able to interact with the surface, and that's why the pressure is low. So that's what basically Bernoulli's theorem means. Now, coming into Newton's third law, Newton's third law basically means that for every action there is an equal and opposite reaction. Now, looking at the example here, the rocket burns the fuel and pushes it downwards. Since the rocket is pushing the fuel downwards, the fuel pushes the rocket upwards. The rocket pushing the fuel downwards is the action, and the fuel pushing the rocket upwards is called the reaction. So basically, it says that there is always an equal and opposite reaction to every action.